Okay, in this video lesson, we're going to take a look at this idea of heat and temperature and kind of separate those two a little bit, okay? So first of all, when we say the word heat, that actually means something in chemistry. It doesn't just mean hot, okay? So kind of keep that out there as we go through this lesson, that when you see the word heat, you should not think warm as you do this, which is different than our everyday speech, okay? So officially, heat, or the fancy word we use for it in sciences, is enthalpy, okay? It's the total amount of energy in a system. Okay, so you take any system we have, anything that we're studying, anything that we're looking at, anything that we're trying to compare, and it's all the energy inside that system. Okay. Usually, it's a way of us talking about thermal energy, okay, or heat energy or enthalpy of that. It's different from temperature because temperature is the average amount of kinetic energy in a system. Okay, so in this case, we're looking at that average because we know that particles move all at different speeds and that we can only track the average speed of all those particles inside of our sample. So that's what temperature does for us, okay? Now, that has some interesting repercussions because if we're looking at the total energy in a system and we're looking at versus the average, if we have a bigger system, the energy will be more, right? If we have a smaller system, the energy will be less. So the amount of particles we have there plays a role here also, okay? So we want to get away from this idea that heat means hot in our world, and let's take a look at that or an example of that, okay? So if we take a look, this is a fin of a whale, if you didn't know what that was. It's kind of hard to see, but this is the ocean, okay? Now the Atlantic Ocean is about 50 degrees Fahrenheit, on average, okay? And a hot tub, usually about 102 degrees Fahrenheit on average, okay? So of the two, which one has more enthalpy, heat, and which one is hotter? Are they both the same? Are they both different? Okay? Think about that for a second before you move on with this video and see if you can answer that. So which one is hotter? Hopefully this is a pretty easy one. But then which one has more enthalpy or heat? Okay, so here we go. So obviously the hotter one is the one that's going to have a higher temperature, which means the average kinetic energy inside of here is more, okay? But in terms of total energy, okay, if we take all the water in the entire Atlantic Ocean, okay, even though it's colder, all the water in the entire ocean is definitely going to contain more energy overall than just one hot tub is, okay? So there's a difference between those two things that we want to make sure we're careful about. So when we talk about heat, we're actually looking at the total energy available, even though it might be cold to the touch for us, because remember, we're only like 1 point in the temperature scale too. Like just because we are 98.6 degrees Fahrenheit doesn't mean the world revolves around our base temperature, okay? Now, that brings us to this idea of enthalpy, or like how we're going to use it, okay? So enthalpy is that fancy word for heat, and it's basically going to be how we're going to track the changes in energy content of a system, okay? We don't usually ever like try to define the total energy content, but we usually track the change. So you notice how instead of saying enthalpy, it'll be the enthalpy change all the time, or a delta H. So H is our symbol for enthalpy. The word enthalpy and heat can be completely interchangeable. So if you see the word heat or the word enthalpy, it means the exact same thing. It just depends on which textbook you're reading or online source you're looking at or what teacher you're talking to, okay? The delta symbol obviously is our change. If you take a look, we have lots of different ways that we can track energy change or heat change in a system, okay? So we have the delta H of a reaction, RXN. We have the delta H of a solution. These are the first two we're going to cover as we go through this unit. And then we have energy changes for melting, freezing, boiling, and condensing. So they're all energy changes. They're all enthalpy changes, heat changes. So they're all the same, really. It's just different systems or processes that we're going to cover that covers that. That's why they're all delta H's. The little subscripts just tell us what thing we're talking about. Also notice that you have delta H of F, that's a positive number, for melting. Well, then freezing, it's the opposite of it. And boiling, it's a positive number. Condensing, it's the opposite. So really, we're talking about two things. Heat of reaction and heat of solution act identically. So basically, this is one thing we're talking about. Melting and freezing is one thing, just opposites. And boiling and condensing is another thing, just opposites, okay? So we're really looking at kind of like these big things in the world of heat in this unit, okay? Now, that leads us down to this idea of thermochemical equations, and that'll be in our next video.